super complex video game you love to the simple app that orders your morning coffee, we are literally surrounded by software. And it all seems so impossibly complicated, right? But what if I told you that all of it, every single piece, boils down to just 3 secret rules? Well, let's pull back the curtain and see how it all really works. Seriously, have you ever just stopped and wondered about that? How does a program actually decide what to do next? How does it make any sense of all the information and commands we're constantly throwing at it? It kind of feels like magic, but the reality is something way more elegant. It's all about logic. And that logic, the entire foundation for every single piece of software ever written, is built from just 3 simple, fundamental building blocks. That's it, just 3. And once you get these, you basically understand the secret language of all software. All right, so let's dive into the first rule. This is the absolute bedrock of all programming. You have to follow the steps. In the programming world, this is called sequential processing, and it's pretty much exactly what it sounds like. The computer does one thing, then the next, then the one after that, in a perfect, unbreakable order. No skipping around, no jumping ahead. It's just one foot in front of the other. A really great way to think about this is like following a recipe for a cake, right? You can't stick the cake in the oven before you've mixed all the ingredients. You got to follow the steps in order. That's sequence. It's simple, it's powerful, and it is absolutely essential. Okay, that makes sense. But what happens when a program it needs to do something different depending on the situation? Well, that brings us to our second and super important rule: make choices. This is where software starts to feel smart. It uses something called selection processing. Basically, the program asks a question, a condition, and then, based on the answer it gets, it decides which path it's going to take. This is what lets an app react differently to whatever you do. So at the very heart of this is a decision point, almost like a little gatekeeper asking a question. Is this condition true or false? Is the answer yes or no? And depending on that answer, the program flows down one of 2 different branches. It is literally a fork in the road for the code. And programmers have a couple of main tools for this. First up is the simple if statement. Think of it like this: if this is true, then do that. And if it's not true, well, nothing happens. It just moves on. But then you have the if-else statement, and this gives us a real choice. If this is true, do that. Otherwise, do this other thing instead. Now you have a path for both outcomes. So let's look at a quick if example. The program checks one thing. Is the student's grade 60 or higher? If the answer is yes, great, it prints passed. But if the answer is no, the program just keeps going and stops. See? It either does the action or it just ignores it completely. Now, look how this gets better with an if-else. We ask the same question: is the grade 60 or higher? If yes, it prints passed. But else, which just means if the answer is no, it now has another job: print failed. Now there's a specific outcome for every single possibility. No more dead ends. And this is where it gets really powerful. You can nest these choices inside of each other. Like, if the grade is over 90, print A. Else, if it's over 80, print B. Else, if it's over 70. You get the idea. This is how you build these huge, complex decision trees, all from simple yes or no questions. So we've got sequence and we've got selection. But what if you need to do the exact same thing over and over and over again? I mean, imagine having to write the same line of code 1,000 times. That's just impossible. And that brings us to the third and final rule: repeat yourself. So programmers call this iterative processing, but you've probably heard it called something much simpler: a loop. A loop just tells the computer, hey, repeat these actions as long as this specific thing is still true. This right here is the absolute key to efficiency. The whole process works just like a merry-go-round. The program gets to a question, and as long as the answer is yes, it does something and then goes right back to ask the same question again. Round and round it goes, until finally the answer is no, and it gets off the ride. Here's a super practical example. We start a counter at 0. The loop's rule is keep going while the count is less than 5. Inside that loop, it displays our message, and then it adds 1 to the count. It'll do this 5 times. When the count is 0, then 1, 2, 3, and 4. As soon as that count hits 5, the rule isn't true anymore and the loop just stops. It's a really simple but incredibly efficient way to get a task done again and again. And there's a small but really important difference in how loops can work. The while loop we just looked at is kind of cautious. It checks the condition before it does anything. So if the condition is false from the very start, that loop will never even run once. But then you have a do while loop, which is a bit more bold. It does the action first, and then it checks if it should do it again. This guarantees that the action runs at least one time. So, there you have it, our 3 rules: sequence, selection, and iteration. Or, following steps, making choices, and repeating yourself. But here's the most amazing part. What happens when you start putting them all together? Okay, just let this sink in for a second. All logic problems can be solved using only these 3 structures. Every single one. From the simplest little calculator app to the most advanced artificial intelligence. And that's because you can combine them in any way you want. You can put a choice inside of a loop. You can have a sequence of steps that leads to a decision, which then kicks off another loop. This whole process of attaching them end to end is called stacking, and it's what allows these 3 simple rules to create literally infinite complexity. So the next time you use any piece of software, just remember what's going on under the hood. It's just this beautiful, complex dance of these 3 basic things: sequence, selection, and iteration. That's the secret. These 3 rules build our entire digital world. So the only question left is, what could you build with them?